Hello. Let's continue with Unit 2 review solutions. This is part 2, numbers 13 through 20, your graphing part. On number 13 and 14, you're asked to graph the piecewise function. All right, on 13, y equals 2x plus 3 when x is greater than or equal to 1. Y equals negative x if x is less than 1. And if you recall, I told you to take each part. For example, we got y equals 2x plus 3 is one part. Y equals negative x is another part. And when x is greater than or equal to 1, when x is less than 1, you need to plug in whatever number is in your inequality to figure out your starting point. So I'm going to take and plug in 1 for x to see what my y value is, and I'm going to get 6. So my starting point is 1, 6. That's where I start. My slope is 2. So slope is 2. So that's what I'm going to use to graph that line. And it was x greater than or equal to 1, so I only want to see the right side. For this part, I'm going to plug in 1 for x, and I get y equals negative 1. So I'm starting at 1, negative 1. Don't be careful with negative. I only plugged in 1 for x, but I got out negative 1 for y. So that's where I start with this line, and I have a slope of negative 1. Slope of negative 1, it was x less than 1, so I only want to see the left side. Okay, we are starting, my turning point, or my point at which it changes behavior, was positive 1. So this is actually where we start with both graphs. For the red graph, my starting point was at 1, 6, and that's going to be a filled in hole. That's going to be closed. So 1, 6 is here, and I said I only want to see the right side. And it's got a slope of 2. So I go up, rise over run, so up 2 over 1, up 2 over 1. Let's go another one. And so that's that part. And for the green part, my starting point was at 1, negative 1. And this is an open hole because it had just less than. So 1, negative 1, open hole here. And I only want to see the left side. My slope was negative 1, so I know my line should be going downhill through that point if you're reading your graph left to right. So I use my slope of negative 1 going up, which is positive, but to the left would make it negative. So point here. You can do that one more time. Okay, for 14. have y equals 1/2 x minus 4. When x is greater than 6, I have negative x plus 5. When x is sandwiched in between negative 4 and 6, notice that those are both less than or equal to, so those holes will both be shaded in. This hole is going to be open. For the bottom part, I have 3x plus 1 for when x is less than negative 4. That will also, so this is going to be an open hole. Both holes here are going to be closed. This will be an open hole. Okay, so let's examine each piece. I've got this piece, y equals 1/2 x minus 4. When x was greater than 6, so I take my slope is 1/2, notice that. Slope is 1/2. Take 6 and plug in, so I have 1/2 times 6. Half of 6 is 3. 3 minus 4 is negative 1. I plugged in 6. So for this part, I'm starting at 6, negative 1. My slope is 1/2. But I only want to see, it was just x greater than 6. So remember, that's an open hole, and I only want to see the right side. So that's what I know for my first part. For the middle part, I have y equals negative x plus 5. And I'm going to plug in negative 4 and 6 to see where it starts and where it ends. When you have a compound inequality or a sandwich, you plug in the starting and ending points. So I have negative 4 plus 5. So y equals 4 plus 5, which is 9. So where it starts is at negative 4, 9. And then I plug in 6. So I got negative 6 plus 5. So y equals negative 1. So where it ends is 6, negative 1. And once again, be careful. All I did was plug in 6. I didn't plug in negative 6. So it starts and ends there. And if you'll just plot that first point and the second point and just connect your line, you're fine. You don't have to worry about the slope being negative 1. It should go downhill though. Knowing that the slope's negative 1, that part should go downhill. Last part, we have y equals 3x plus 1, and that was when x was less than negative 4. Oh, by the way, going back here, that's going to be closed. That'll be closed too, and the reason is we had that equal to. So that's our middle piece. Okay, for this part, I plug in negative 4 to see where I start. You get negative 12 plus 1, which is negative 11. So I plugged in negative 4, starting at negative 11. My slope is 3. So slope is 3. It said x is less than 4, so I know that's going to be open hole. And I only want to see the left part of that graph. Okay, so let's draw a graph. It should, based on where you're starting and your slope, the y-axis should go up. We may have to draw it may have to go by 2. Okay, your highest y coordinate is 9, but then a slope of, yeah, so the highest y is 9, so we're good there. So we'll go, I'm still going by ones, but I'm just going to label every other number to make it a little bit easier to see. Okay. So to graph the part in red, we're starting at 6, -1, slope of 1/2. Starting at 6, -1, my slope was 1/2. And it's x greater than 6, so I only want to see the right, and we know that that's open. So 6, -1, open hole. And I only want to see the right side, so I'm going to use my slope of 1/2, go up 1 to the right 2, up 1 to the right 2. And your graph will keep doing that in that direction. For the part in purple, we had that it starts at -4, 9, and it goes to 6, -1, and both of them were closed. And recall, we said its slope is negative, so it should be going downhill, but let's graph it and see. So -4 all the way up to 9, and that was a closed hole. And 6, -1 was a closed hole. So notice that it gets filled in with that solution. And if you draw your line through those points, or going from one point to the other, that's that part of your graph. Okay, the next part in green, last but not least, it started at -4, -11, and that's an open hole. Slope is 3, and it's x less than -4, so I only want to see the left part of my graph. So once again, -4, 11, -4, -11, and that's an open hole. And my slope is 3, so this line will be positive slope. So if it's a positive slope, but I only want to see the left side of it, I have to use my slope to get points down in this location, since I know the whole thing would be positive if it were graphed completely. So using my positive slope of 3, I actually can go down 3, which is -3, into left 1, which is -1, but that creates positive 3. So down 3 to the left 1. And then when you graph through that part. Now, if you wanted to condense your graph, notice that I made this graph really big, but if you wanted to condense it and actually go by 2s on the y-axis, like 2, 4, 6, 8, and so on, to make it smaller, you can. That's fine. I would still leave the x-axis 1s in this case, but okay, so that was number 14. Moving right along. Okay, 15. We're almost getting there. 15 asks you to graph either the absolute value of the equation or the inequality, and label the vertex and x-intercepts and y-intercepts if there are any. So 15, we have y equals 1/3 x, ooh, fractions, that looks fun, equals 1/3 x plus 6 minus 3. Okay, I'm going to show you how to graph all of these using vertex form to make it easier on you. Except for when we get down to 19 and 20. But on 15, if you will recall, vertex form for an absolute value, vertex form of absolute value is y or f of x equals a times x minus h plus k. And h and k is your vertex point. That's where the absolute value graph comes to a V point. Notice that it does the opposite of h. Notice that I have a minus h in my formula, but in my vertex, I only have h. So you always do the opposite of h. So in this case, my vertex is, and vertex is your starting point. So my vertex is -6, because I did the opposite. This is your h and k. Notice that k stays the same. So k, so I always do the opposite to get h, but k is the same. Opposite to get h, k is the same. So -3. That's where I'm going to start on this graph. That's the point that it should come to a V. Now, okay. A is actually your slope. And this is how you get your other points on both sides of that V. So on the right side, when x is greater than h, for example, this is 6. So when x is greater than 6, when x is greater than -6, so to the right of -6, I'm going to use slope of positive a to get those points. Where x is less than h, so in this case, when x is less than -6, to the left of the graph, to the left of that vertex point, I'm going to use a slope of -a to get those points. So you're going to see that in this example. So on 15, All right, on 15, your vertex is negative 6, 3. Notice that your slope, my slope is 1/3. Slope is 1/3. That's what A is. Compare this form to what you have. So I'm first plotting my vertex at negative 6 and negative 3. So negative 6, 3 is here. Then I'm going to use my slope. So when x is greater than negative 6, I'm going to use a slope of 1/3. So I go up 1 to the right, 1, 2, 3. Up 1 to the right, 1, 2, 3. To get that part of the graph. When x is less than negative 6, I use a slope of negative 1/3, and my line should be going downhill. So to get that negative 1/3, I can go up positive 1 to left 3, which is negative 3. So I get that piece, up 1 to left 1, 2, 3. So I have this part in purple. Or of course it forms one entire graph, but just to show you how you would use the vertex form. And then this part of your graph for the green. Okay, so just to reiterate, the number in a spot will be your slope, and that's what you use to get the right side and the left side past your vertex. So you're plotting your vertex point, the opposite of the number inside with x, which would be negative 6 in this case. Keep that number outside the same, so that's your vertex. We plot that point. To the right of my vertex, I use the positive slope. To the left of my vertex point, to the left, I use the negative slope. Okay, let's graph 16. All right, on 16, we have y is less than negative x minus 3. This graph is going to be flipped down because that's a negative. So when you see a negative out front, negative means the negative sign means your absolute value graph is flipped. So this one's going to be an upside down V, and it's an inequality. So I'll show you how to graph this in vertex form, just like we just did the other one. So since it's going to be upside down, it changes everything. So I've got A, that was my vertex form, just to recall. So the number, notice that there is no number in K's spot. So my vertex is 3, 0. This was H, and I do the opposite. And there is no K value. So K is plus 0. Now, we already said this is going to be flipped, so I know when I am greater than 3, I'm actually going to use the negative slope. So it flips things around. So use the negative slope, And notice that your slope is -1. So slope is -1. When x is less than 3, so to the left side, I'm going to actually use the positive slope because it flips things around. So use positive slope here. Okay, we're going to start at our vertex point, which is 3, 0. So plot that first. Plot first. And then we're going to use the negative slope to the right. So to the right, we're going to use the negative slope of -1. So I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And then on the left side, I'm going to use a positive slope, which will be down to left, which creates actually a positive. And voila, you graphed your parabola. Well, except for, I totally just messed that up because this technically should be what? This is an inequality. So glad I caught that. Okay, so you graph it the same, like I'm going to use the slope and everything. The only thing, can anybody see what I did wrong? It should be a dotted line because, so you've got less than, this should be dotted, and then we have to test where to shade. So remember, as you see, I forget to. So remember, it should be dotted. Dotted line and test for shading. Alright, I like to always pick the origin if it's not actually on the dotted or solid line. So I'm going to use 0, 0. If I get a true statement, I shade in that region. If I get a false statement, I shade in this region. And we have to plug it into the original. So 0 less than -0 minus 3 in absolute value. Let's see if I get a true statement. 0 is less than -3 because the absolute value of -3 is 3. And then that still keeps it negative. And so that's false. 0 is not less than -3. So I shade here in this area. Okay, 17. 17, I have y equals 5 times the absolute value of x plus 1. This is in vertex form. And it's positive. So I have a positive 5. So it's positive. So I know my graph will be upright and will look normal. And recall that vertex form is a times x minus h plus k. So my vertex, notice that I don't have, this is like if I had 5 times x plus 0 plus 1. So this would be H and that would be K. So my vertex is 0, 1. And your slope is 5. So to the right, when x is greater than 1, it's just like what we think. Notice that like to the right of the vertex, it's going to go up. So I'm going to use positive slope to the right when it's greater, and it was 5. When x is less than 1, to the left of the vertex, I'm going to use the negative slope of -5, -5/1. Okay, so let's plot our vertex point of 0, 1. And I'm going to use the slope of 5 to go to the right. So we're going to go up 1, 2, 3, 4, 5. To the right 1. We can do it one more time if you wanted to. It doesn't matter. 1, 2, 3, 4, 5. To the right 1. And you do that on the left side except for the opposite direction. 1, 2. Notice that absolute value graphs, of course, are symmetric. So notice that here's my vertex, and I've got a point across this line or axis of symmetry. And you can also use that to help you graph them. And I'm just using the different colors to show you how you get your parts. Okay, 18, we're nearing the end. We have y plus 2 is greater than x plus 7. Okay, so let's subtract 2. Let's isolate x. And then notice that you'll have it in vertex form. So vertex form, once again, just to recall. So vertex is -7, -2. And this is an inequality. So we're going to have to see, we get a dotted line, we get a test for shading, all of that after we graph it. All right, and we don't have any negatives, so this one will be upright like we think it should be. So to the left, I'm going to use slope. My slope is 1, by the way. Notice you don't have a number out front, so it's understood to be 1. So left slope, -1. Right slope, we're going to use +1. All right. And then we're going to have to test for all of the shading. Okay, so -7 would be here, and -2. So plot your vertex, -7, -2. Use the slope to the right of +1. It should be upright because this coefficient in front is positive. So I'm going to go up 1 to the right 1. So use the slope that way. Use your slope to the left to do the same. Negative. So you see that? This is greater than, so it should be dotted. and we have to test for shading. So I know it should be dotted. Dotted and test for shading. I love the origin, you already know that. So I'm going to plug in the origin into my original, 0 plus 2, greater than 0 plus 7. I get 2 greater than 7. And we definitely know that is false. So notice that this graph would keep going up that way forever. This graph, of course, would keep going up that way. The origin is in this region, this entire region. This V bounds that region off. Since I got a false statement in that region, nothing will work. So my solution set is actually like up here in this region and so on. So that's why we shade in that area. Okay, last but not least, 19 and 20. Well, almost last. 19, y equals x plus 2 plus x. So in this case, I'm going to show you how to rewrite these as a piecewise, which is the first way that I showed you how to graph absolute value. So let's rewrite this one. If it has an extra variable like the x, I always like to do these this way. So rewrite into piecewise. So my turning point would be -2. Turning point is -2, put that in the middle. And then on the left side, if I plug in numbers smaller than -2, notice that it would make these insides negative. And that is the case where you change all of the inside and leave everything else. If I plug in numbers higher than 2, it's going to be positive inside. So that's where I leave it the same. And that was when x was greater than or equal to -2. And this is when x is less than -2. Okay, so if we rewrite that into a piecewise, let's go ahead and clean this up. Notice that this part, you just get -2. Your x's cancel. So I got y equals -2, which is a horizontal line, when x is less than -2. For this part, I have y equals 2x plus 2 when x was greater than or equal to -2. When we graph that, so we have y equals -2, that's a horizontal line. You're going to have an open hole at -2, -2, and it's going to be going straight across to the left. And then, so you're going to start at -2, -2, and go to the left. All right, for this part, y equals 2x plus 2, x is greater than or equal to 2. You're going to plug in so you can see where you start. So plug in -2 for x, and you're going to get -4 plus 2, which is -2. So you're going to start at -2, -2, and that's going to be close. Notice that they share the same starting point, which is what you should see. And my slope was 2. This is a horizontal line. All right. Let's start with the purple. We're going to start set at x is -2. And I've got a line y equals -2. So I'm starting at x equals -2, which is here. But I have a horizontal line through y is -2. It's open at that point, and I only want to see the left side. So there's the part in purple. For your graph in green, you're starting at -2, and that hole got filled in. And you're using your slope of +2, and I do want to see the right side because it was greater than. So I go up to the right one, up to the right one. All right, last but not least, 20. Y minus 3 greater than or equal to x plus 5 minus 2x. So let's add the 3 to the other side. So I have x plus 5 minus 2x plus 3. We need to rewrite this into a piecewise as well. So turning point is -5. And the reason that we wrote 19 and 20 both into a piecewise, it had the extra x. Like in this case, notice you got the extra x outside. So vertex form will not work for that one, and you have to rewrite those in piecewise. All right. To figure out how to do that, you've got your turning point in the middle, -5, and we're going to see what happens when x is less than -5 and what happens when x is greater than -5. When I plug in numbers less than -5 into this, you get negative. So this case is where it changes. So you're going to say -x minus 5, and the minus 2x plus 3 stays the same. When I plug in numbers greater than -5, these insides are positive, so it stays. So I got x plus 5. The minus 2x plus 3 stays the same. Well, all of it stays the same here for this part. And we're going to add the equality part where it stays the same. All right, let's clean this up, put it in piecewise, and see what we got. So we have, if I combine like terms, I have -3x and minus 2. And then for this part, I have y equals -x plus 8. So this was when x was greater than or equal to -5. This is the right part of your graph. This was when x was less than -5. This is the left part of your graph. All right, let's plug in our starting numbers -5 to see where we start. Since it's absolute value graph, your starting point should be the same. But let's take a look and see. So I have y equals -3 times -5 minus 2. So I get y equals 15 minus 2, which is 13. So I'll start at -5, 13. And slope is -3. Slope is -3, and I only want to see the left side. Okay, plug in -5 here. I have -5, which creates +5. So I get y equals 13. So I'm starting at -5, 13. Starting points are the same, so that's good. And I'm using my slope of -1. And I only want to see the right side of my graph. Okay. So on this graph, I'm starting at -5. -513 for both of them. It's going to be, it would actually be open for this part and closed for this part, but notice it gets filled in. So -513. Okay, and that would be open, but it's going to get filled in anyway. So open, and then you're going to use a slope of -3, so your line should be going downhill, but I only want to see the left part. So I use slope +3, -1. So you go up 3 to left 1 to get that side, up 3 to left 1. Then the pink parts also starts at -513. This is where it would actually get filled in because that's a filled in hole. And then I would use my slope of -1. And go up 1 to the right 1, 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 so on. Okay, this is a greater than or equal to, so this is solid, and we want to test. So I know it's a solid graph, solid lines, and notice that the origin is way down here, so I'm going to use it to check. So I've got 0, -3, greater than or equal to, 0, +5, -2. Notice that you got another 0 that you have to plug in x for. So you have to do that everywhere. And let's simplify. I got -3, greater than or equal to, absolute value of 5 is 5. This becomes 0. So is -3 greater than or equal to 5? No, that is false. Okay, hang on, this part, I'm so sorry. This part should be, that should have a negative slope. My bad. I'm sure some of you picked up on that already. All right, from this point, we actually have to go down 1 to the right 1, down 1 to the right 1. That should have had a -1 slope. I wrote it with a +1 slope. Okay, so in this case, but it's still going to be solid. All right, so when we tested the origin, it was false. So I know that I'm not shading in this area. We're not shading here. My solution section will be in this region here. Okay, and that concludes Unit 2 review. Hope this helped. Have a great day.